Okay. So now we're recording. So let's talk about relations and functions. So a relationship is pretty straightforward. It's just, you're trying to relate X and Y values. Any equation is a relationship between two variables, usually X and Y. Here they can be pretty simple, like, make sure you know your quadrants, 1, 2, 3, 4. In ordered pairs, obviously we have X and Y coordinates. We can express coordinates in a table or a mapping diagram. To determine whether something represents a function, you have to pass the vertical line test, which you guys hopefully are familiar with. So vertical line test means that whenever you draw vertical lines, you cannot pass, you cannot cross more than one point. So basically for each input, there's only one output. See, B would fail because I'm crossing both these points with one vertical line. Here, C is okay because X is not repeated. So every X has its own unique Y value. Of course, that's no, because if X equals -2, there's two different outputs. Now here, the output of -2 has two inputs coming into it, but that's okay. Every input's unique. So, but they don't really ask these yes/no questions on the SAT, so don't worry about that. But it's just kind of good to understand that, a function is a relationship between X and Y in which X occurs just once. So you can't have like something like this here is not okay. X equals -3 leads to two outputs. We can't have that. So that's the definition of a function. Vertical line test I just discussed. Again, no vertical line can intersect graph more than once. Plugging into functions should be pretty straightforward. So fx equals 3x plus 2. It's no different than saying y equals 3x plus 2. And when you see something like this here, that simply means you plug in x equals -2. So you plug -2 into this function here, and you can see down below they show you how it works out. So they're all worked out. C is a little more involved. You have to do f of -1, then multiply by -2, and then add to f of -2. Again, if you're just very careful, methodical, you should be fine. B and D are a little bit funky. Here you're replacing x with an expression, not a number, but still no different. Instead of 3x plus 2, you do 3c minus c plus 2. Or for D, instead of 3x plus 2, you do 3 times -12 x plus 1, then plus 2. So that's what's happening there. And then you just kind of clean it up after that. So we'll definitely work through some multiple choice problems just a little bit, but these are just more conceptual overview. So let's actually do, just trying to think what's good for us to do. Definitely want to do 4 because we just saw that. Yeah, we'll do 4 and 7, and I'll have you guys do the other problems in your breakout rooms. So 4 and 7. So let's look at number 4. So instead of -2x plus 7, replace x with the new input, 1/2 x plus 3. So all of x gets replaced by all this over here. So it's -2 times 1/2 x plus 3. If you go and distribute, you should be okay. -x minus 6 plus 7, -x plus 1. So the answer is A. So that's how that would go. Any questions about number 4? Nope. Yeah, cool. And by the way, we will go till about 5:30 today. That's the plan. So we'll try to just power through this. But if you do need to get up and get a break, I mean, stretch break or use the bathroom or get something to eat or drink, totally fine. Let's take a look at 7. So remember, the whole point of functions is input versus output. That is your input. 7 is your output. And that's our function. So if I input -2, f of -2 is simply going to be the square of -2 minus b. Or -2 times -2 I know is 4, so 4 minus b. Apparently f of -2 equals 7, so that's going to be my output. So 7 equals 4 minus b. If you solve for b by subtracting 4 from both sides, b will be -3. But we're not out of the woods yet. They're not asking for what b equals. And by the way, if this was one of the free response questions in the SAT, the answers are never negative. They're always going to be 0 or positive numbers. So if you think the answer is -3, you should do a double take because that can't happen. But they are asking for f of -3. So you just do it again now. But remember, the function is now x squared minus -3 or x squared plus 3. That's the new function. So plug in -3 for x. And you should get 12 as your answer. And then the way the grids would work, it would look like this. I'll go back to the PDF one more time, but give me one sec. Yeah, so you just, would, put 12, 1, 2, and then you just do that. You could put the 12 here if you like. That's fine. Or you put in the middle. That's also fine. What you don't want to do, which I don't know why you would do this, don't do that. Or don't do that. Or don't do that. I mean, that just wouldn't make sense. I'll just put the 1 and 2 next to each other. You do have to fill out the bubbles, though. Now, if you did this, they still give you full credit, even if you don't put anything up here. Because really, it's just going to read the bubbles. But if you do this and do nothing over here, you won't get any points. So make sure you fill out the bubbles. So again, the answer was 12. Let me go and erase some of this other stuff here. It's a little distracting. Remember, -2 is the input, plug -2 into the function. You got square -2, that's 4. 4 minus b is our output. The output's also equal to 7, because they told us that. So you set 4 minus b equal to 7, solve for b, you get -3. So the new function now is x squared minus -3 or x squared plus 3. And you have to do f of b, meaning what we solved for b earlier on is now our input that we plug into x squared plus 3 and work it out. So you have a chance to kind of practice these skills in your breakout rooms. So you guys will do 1, 2, 3, 5, 6 in just a little bit. Before we go to the breakout rooms, let's talk about 3-2, rate of change and slope. So slope's a big deal. Very straightforward, change in y or change in x, rise over run, as we tend to know that. Obviously, if it's sloping up from left to right, or basically as x gets bigger, y gets bigger, that's a positive slope because both changes are positive. Or you could think of both being negative if you go from right to left, but regardless, the slope is still a positive value. This is more downhill, so that's a negative slope. Horizontal lines have 0 slope. Vertical lines are undefined because the change in x is 0. Like say that's like 2, 1, and say it's 2, 4. If I subtract the y's and subtract the x's, guess what? I'm dividing by 0. You can't divide by 0, that's undefined. Equations can be expressed in a way like this. That's called standard form, and x are on the same side. We will talk about y equals mx plus b in just a little bit. X-intercepts is when y is 0. So if you're touching the x-axis, so y is 0 here, then of course that's the x-intercept. Y-intercept is when x is 0. So when you're touching the y-axis, that's an x. Sorry, that's a y-intercept when x is 0. Obviously, when y is 0, we also call it the zeros of the function. Function 0 is the x-intercept. So some terminology there, which we'll emphasize with quadratic functions. Probably we'll do quadratic functions in a couple of weeks. Let's look at some examples here, and then we'll do a couple here, and then we'll do the breakout rooms after that. So here we have a table, Evan's height from ages 12 to 18. And apparently it's kind of consistent, but not really. But you're asked to find the average rate of change from ages 12 to 18. Average rate of change is always going to be slope. Because you're doing a change, right? The change in something or change something else. So the change in height over the change in age. So from 12 to 18, the height went from 61 to 70, or 70 minus 61. And the age went from 12 to 18, or 18 minus 12. So he gained 9 inches in 6 years. That's why it's 1.5 inches per year. And notice the units. The units are also in a ratio. So that's what we expect for slope. 2 is very straightforward. So they subtract the y's, 4 minus negative 2, 5 minus 3, sorry, negative 5 minus 3. You get that. And example 3 is also very straightforward. If you want x-intercept, replace y with 0, solve for x. If you want y-intercept, replace x with 0 and solve for y. So again, very straightforward there. I'll do 3 and 7. So you guys will do 1, 2, 4, 5, 6 in your breakout rooms. So for 3, if slope of graph f is 1, which of the following is true, and it gives 2 points here. So you subtract the y's, b minus 1, subtract the x's, 1 minus a, equals 1. And because they're asking you to put a and b on the same side, I'm going to cross multiply, add a to both sides, add 1, a plus b equals 2. And there you go. So that's why the answer is D, actually. Easy peasy. So that's number 3. Number 7 was a slope. Well, that's just getting y by itself. So 4y equals x plus 6, divided by 4. So now you have in slope-intercept form, which we'll talk more about in the next section. So your slope is just 1/4. Remember, y equals mx plus b. So we kind of just moved things around there. Okay. So any questions so far? Nope. Okay. So 3-1 and 3-2. Definitely 1, 2, 3, 5, 6 from 3-1. 1, 2, 4, 5, 6 from 3-2. So it's total 10 problems. I think 10 minutes should be sufficient for going through those. So we'll do the breakout rooms. Actually, we'll say 12 minutes, give you a little more time. And then after that, then we'll come back and we'll do 3-3 and 3-4. And then we'll do 3-5, 3-6 after that. So let me do the breakout rooms right now. And actually, I'll stop the recording so I can label them appropriately.